We are going to start now the next chapter of class 10th mathematics. It is triangle. Now first we talk about some basic definitions related to congruent and similar figures. So we have already studied in our previous class the definition of congruent figures. So we are saying two figures, they are congruent if they have exactly same shape and size. We have studied congruent triangle, congruent circles. So we are saying they have exactly same shape and size, or we are saying that if we overlap those two shapes, then they will overlap completely with each other. If we keep them on one another, then they will overlap completely with each other. So congruent figures are alike in every aspect. It is written over here that congruent figures are alike in every aspect. Next thing we have is, the definition we have is, it is similar figures. So similar figure means the geometric figure which have the same shape but may have different size are known as similar figures. So we are saying that if we talk about some example over here, we are saying suppose this is a triangle, this is another triangle. The shape of both these, it is same. Shape means if suppose I am saying this is an equilateral triangle, all the three sides they are equal. This is also an equilateral triangle, all the three sides they are equal. So if the length of this side is A, the length of this side is B, their lengths are not equal, but their shape is same, but sizes they are different. So these two triangles, we are saying these are the similar triangles but not congruent. But if we have two congruent triangles, then they will be similar also. We are saying if they have the same shape and size, then they have the same shape. Next we are saying, these are some examples over here. We are saying if two lines are given to us, these are the two lines that are given to us, then these lines are always similar. They may or may not be congruent. They will be congruent if their length is same. If their length is the same, then they are congruent. But their shape will always be same. So we are saying two line segments are always similar. If we are talking about two triangles over here, suppose we are saying these two triangles, these are both of these triangles, these are equilateral triangle. Then we are saying both these triangles, they have the same shape and we are saying they are similar to each other. Next is any two squares are similar. These are the two squares we are talking about. These are given over here, these are similar. Any two circles are similar. These are the two circles we are talking about. So both these circles, they are similar. So these are some examples of the similar shapes. Next we have similar polygons. So two polygons having the same number of sides are said to be similar if their corresponding angles are equal and the length of their corresponding sides are proportional. This is the definition for similar polygons we are talking about. Polygon means any figure we are talking about which is having n sides. We are talking about the figures which are having n sides, that is called a polygon. Plane figures we are talking about. So two polygons having the same number of sides. First condition is that they should have same number of sides. Second, we are saying their corresponding angles are equal. And third, we are saying is the length of their corresponding sides are they are proportional. We are not saying these are equal. The word proportional is used over here. That is the ratio, it is same. So we are saying if we have two polygons, one is the polygon A, B, C, D, E, and second polygon we have it is P, Q, R, S, T. Then we write these two polygons, these are similar in this way. This symbol we are saying, this is the symbol for is similar to this symbol we are talking about. And we are talking about the congruent, we were writing it is congruent to. Now we are talking about this symbol only. This is the symbol for congruent, this is the symbol for similar. The constant ratio between the corresponding sides of the two similar figure is known as the scale factor. So we are saying suppose we are talking about this is a triangle, right angle equilateral triangle. This is another triangle. Or if I am saying this is a line, this is another line. This is a circle, this is another circle. So we are saying the, if in case of line I am talking about, the length of this line it is L, the length of this line say it is 2L, then the scale factor is ratio of these two, it is 2L over L is equal to 2:1. So scale factor over here it is 2. If radius over here it is R and radius over here it is say 3R, then we are saying the scale factor over here it is 3. If the length of this side say it is X, in this case this side is X, this side is X, this side is 2X, this is 2X, this is 2X, then we are saying these sides we are talking about, these are X, X and X, these are 2X, 2X and 2X, then the scale factor we have over here it is 2. So the constant ratio between the corresponding sides of two similar figure is known as scale factor. Next is equiangular triangles. So two triangles are said to be equiangular if their corresponding angles are equal. Next we have the definition of the similar triangles. Next is the definition of similar triangle. So we are saying two triangles are said to be similar to each other if first condition is their corresponding angles are equal. We are saying their corresponding angles are equal, and second condition we have is their corresponding sides are proportional. So if any two triangles they satisfy these two conditions, when we were talking about the congruence or the congruent triangle, we were saying that their angle should be equal, their sides should be equal. Over there we have obtained this thing that their sides, their shape, their size, everything is equal. But now in place of equal, the term we are having over here it is their corresponding sides are proportional. This is important over here, that this is the main difference between the congruence and the similarity, that in congruence this word proportional was not there, but it was they are same, they are equal, and in case of similarity we are saying their sides are proportional. The next result we have, or the theorem we have, it is basic proportionality theorem, or it is also called Thill's theorem. So it says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So we are saying, suppose we have this triangle and the line DE, it is drawn parallel to the line BC. Then we are saying the ratio of these sides, that is AD is to DB. We are talking about these two. It is AD is to DB, that is equal to the ratio of the other two sides, that is AE over EC, that is equal to AE over EC. The ratio of these two sides, these are equal to the ratio of the sides AE over EC. Now to prove this we are going to do the construction, and we have joined the points BE. We are talking about this construction over here, that we have joined this point BE and we have joined the point CD. Next thing we have done is, we have from this point D, we have drawn the perpendicular DM on AE. From this point E, we have drawn this perpendicular EL on AD. Now we are going to consider two triangles. One is the triangle ADE. We are talking about this triangle ADE, and second we are talking about the triangle DBE. This triangle we are talking about. So if we write the formula for the area of both these triangles, for this triangle the area is area of triangle ADE, that is equal to half, it is base is AD and height is EL, and area of this triangle we are talking about, it is area of triangle DBE, that is equal to half. We are talking about DBE, so that is equal to half. The base we are considering, it is DB, and height we are considering it is EL. We are talking about when we look at this triangle over here, DBE. For this triangle, this EL is height. If we extend this triangle on this side, here I'm drawing this triangle again. We are having the triangle in this form. So the height of the triangle will be on this side. Now if we divide both of these, what we get is that this EL and EL gets cancelled. These two halves gets cancelled, and we get that the area of these two triangles ADE over area of DBE, that is equal to AD over DB. Next we are talking about the two triangles. One is the triangle ADE, the same triangle we are saying, and second is the triangle EDC. We are talking about this second triangle. So if we write the area of both these triangles, so area of triangle ADE, that is equal to half. Earlier we have considered that AD is the base. Now we are considering that this AE is the base, into, if this is the base, then DM will be the perpendicular. Next we are writing the area of this triangle. It is area of triangle DEC, that is equal to half. Now the base for this triangle, it is EC. This EC is the base. I'm talking about this triangle over here. EC is the base, and this DM, that is the perpendicular. So if we divide both these equations, we get this half gets cancelled, this DM gets cancelled, and we are getting the ratio as area of triangle ADE to ADEC, that is AE over EC. This is the ratio we are getting. Now if we look at these two triangles, that is the triangle we are talking about DEB, and second triangle, this is the triangle we are talking about DEB, and second triangle we are talking about, it is DEC. These two triangles we are talking about, both these triangles are on the base DE, and they lie between the same parallel DE and BC. These are the two parallel lines between which these two triangles lie. So it means the area of both these triangles, that is DBE and DEC, the area of both these triangles, they are equal. It means this side we are talking about, this side of both these equations, left hand side of both these equations, they are equal. So this gives us that AD over DB, that is equal to AE over EC. If the area, that is AD is this length we are talking about, over DB, that is equal to AE over EC, and this is what we have to prove, that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Next is, in a triangle ABC, a line DE, we are talking about this line DE, this is parallel to the line BC, and this AB side it is intersected at D, and this point it is E. Now we have to prove two things. First is AB, this whole length, over DB, this length we are talking about, that is equal to AC over EC. And second, we are proving that AD, we are talking about this length AD over AB, this whole length is AB, that is equal to AE over this whole length is AC. So we are starting the proof of the first part with the basic proportionality theorem, which says that AD over DB, we are talking about this AD length over this DB length, this is equal to AE, we are talking about this length AE over EC. This is the length EC. Now if we add 1 to both of these equations, we get that DB plus AD over DB, that is equal to AE plus EC over EC. So this DB plus AD, this length becomes AB over DB. This will be equal to, when we are adding these two, we are getting it is AC over EC. This we are talking about. So this is our first proof. Now we start with the same equation over here, and we are writing it is DB over AD plus EC over AE. This is not plus, it is equal to these two values, these are equal. Now again if we add 1 to both of these equations, we get is AD plus BD, that is over AD, that is equal to EC plus AE over AE. Now again AD plus BD, this value we are talking about, it is AB, and this EC plus AE, that is equal to AC. So we get AB over AD, that is equal to AE over AC. We will get the similar answer. So these two things, these are just, you can say these are the, we have derived just from the basic proportionality theorem. So these kind of results, these are called the corollaries, that this is the corollary of the basic proportionality theorem, that this is the result of basic proportionality theorem. From this we have proved these two results. So all these results we have written over here in this next slide. So we are saying a triangle ABC is there and DE is parallel to this DE, this is parallel to BC. Then the first result we are saying it is AD over DB, that is equal to, we are saying this is AD over DB, that is equal to AE over EC. This is our basic proportionality theorem. BPT means basic proportionality theorem. Second we are saying is AB, this whole length we are talking about, this AB over this length DB we are saying, that is equal to this whole length over EC. This is our second result. And third result is that AD, the third result we are talking about, it is AD over AB, that is equal to AE over AC. So these are the three results that we have proved. The next result we have, it is the converse of the Thales theorem or the basic proportionality theorem. So it says that if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So we are given that this line is there, we are talking about, say this L line is there, this is intersecting this side AB at the point D and intersecting this side at the point E. Now we are given that the ratio of these two sides, that is AD over BD, that is equal to AE over E. See, the ratio of these sides, these are equal. We have to prove that these two lines, these are parallel. This thing we have to prove. So we are saying, suppose we have that DE is not parallel to BC. We are saying these two lines, these are not parallel. Then we can draw a line through D which is parallel to BC. And this is that line we are talking about. We are saying, suppose this line DF, we are saying it is parallel to BC. Then we are saying by the basic proportionality theorem, we will have AD. How we have drawn this line from this point to D, we are saying we have considered that these two lines, these are not parallel to each other. We have drawn the line DF parallel to BC passing through the point D. Then by basic proportionality theorem we have AD over DB that is equal to AF over FC. Now what is originally given to us? It is AD over DB that is equal to AE over EC. This thing is given to us. So if we compare both these equations, we are talking about this is one equality, this is second equality. The left hand side of both these equations, they are same. So what we get is that right hand side is also same. So we get AE over EC that is equal to AF over FC. Now if we add 1 on both sides of this equation, we are adding 1 on both sides of this equation, we get AE plus EC over EC that is equal to AF plus FC over FC. Now AE plus EC, this is AC, this value we are saying, this whole value, this value is AC, and AF plus FC is also AC. These two gets cancelled, and what we are left with is that EC is equal to FC. So we are saying we are having EC and FC, both these lengths are equal. Now this thing is possible only if E and F, these 2 points, they coincide. If these 2 points coincide, only then this thing is possible. So what we get is that DE is parallel to BC. First, this line DF we have drawn, this is parallel to this line we are talking about DF. It means this DE is parallel to BC. Now the first question we have is, in the given figure, MN is parallel to AB. This MN and AB, these two are parallel. We are saying this BC is 7.5 centimeter. AM is 4 centimeter. MC is 2 centimeter. We have to find the length of BN. So if these two lengths are 4 and 2, then this length will be 6 centimeter. Now by basic proportionality theorem, what we have is, suppose we are saying that the length NC we have, this length we are talking about, this is X centimeter. Then 4 is to 2, that is equal to BN is to X. The value of BN we will have, if this length is 7.5, then this length is 7.5 minus X. So it is 7.5 minus X over X. If we cross multiply these two terms, we get 4X is equal to 2 into 7.5 minus 2X. So we get 6X is equal to 2 into 7.5. This is 3 over here. So the value of X we get, it is 2.5 centimeter. So we are saying this length we have X, it is 2.5 centimeter, and this length BN we are saying this is 2.5 minus X, that is equal to 5 centimeter. Next is, in the given figure, DE is parallel to BC, and it is given that this AD is to BD is 3 by 5. If AC, this length, this is 4.8 centimeter, we are given AD over DB that is equal to 3 is to 5. AC is 4.8 centimeter. We have to find the length of AE. Suppose this length is X, then this length is 4.8 minus X. So we are saying 3 by 5, that is equal to AE over EC. This is by basic proportionality theorem. This is equal to X over 4.8 minus X. So what we get is that 3 into 4.8 minus X is equal to 5X. So 8x is equal to 14.4. So this gives us x is equal to 1.8 centimeter. This is the value of x that we have. Now the next question we have in the given figure, in triangle ABC, DE is parallel to BC, so that AD, this length, it is 4x minus 3, AE, this is 8x minus 7, BD, this is 3x minus 1, and CE, this is 5x minus 3. We have to find the value of x. So by basic proportionality theorem, we are saying AD over DB, that is equal to AE over EC. So what we get is that 4x minus 3 over 3x minus 1, this is equal to 8x minus 7 over 5x minus 3. Now if we cross multiply these two terms, we get 4x minus 3 into 5x minus 3, that is equal to 8x minus 7 into 3x minus 1. On multiplying these terms, we will get it is 20x square minus 12x minus 15x plus 9 is equal to 24x square minus 21x minus 8x plus 7, and this gives us 2x square minus x minus 1 is equal to 0, and this is a quadratic equation in x. And to solve this quadratic equation, we are splitting the middle term, and we get it is 2x square minus 2x plus x minus 1 is equal to 0. So this gives us x minus 1 into 2x plus 1 equal to 0. So we get x is equal to 1 or x is equal to minus 1 by 2. We are having these two equations now, values now. Now we are saying if we substitute x is equal to 1 in these values, we will get the answer from this. We are getting it is 1. For this value, the answer we will get it is 2. For this one, the answer we are getting it is 1, and for this one we are getting the answer is. But if we substitute the value of x is equal to minus 1 by 2, and we are calculating the value of AD, we are talking about this value, and I am substituting x is equal to minus 1 by 2, the answer I will get it is 4 into minus 1 by 2 minus 3, and the answer I will get it is negative, and we are saying this thing is not possible. So we are saying that x is not equal to minus 1 by 2. So what we are left with is that the value of x is equal to 1 by 2. We are getting x is equal to 1. Next is if D and E are points on the sides AB and AC respectively of triangle ABC such that this AB, this length is 5.6 centimeter, this AD, we are saying it is 1.4 centimeter, this length AC, this is 7.2 centimeter, and AE, this length is 1.8 centimeter. We have to show that DE and BC, these are parallel to each other. So we are saying if this length AD is 1.4, then this length BD we are left with is 4.2 centimeter. Similarly, this second length we are talking about, this length will be 7.2 minus 1.8, that is 5.4 centimeter. So if we look at the values, AD over DB, that is 1.4 over 4.2, and if we look at the value AE over EC, then it is 1.8 over 5.4, and both these values, these are equal to, this is 2, 6, 2, 6, both these values, these are equal to 2 by 6 and 2 by 6. So we are saying this AD over DB, this is equal to AE over EC. So by the converse of the Thales theorem or the basic proportionality theorem, we are saying that the line DE and BC, these will be parallel. Next is in the adjoining figure, MN is parallel to QR. This line MN and QR, these two lines, these are given to be parallel to each other. We have to find the value of PN. We are talking about this length is PN, and we have to find the value of PR. So by the basic proportionality theorem, we have PM over MQ, that is equal to Pn over Nr. So this implies us 1.9 over 5.7, that is equal to x over 6.9. We are saying this Pn, we have considered it as x. This Pn, we are saying this length is x. So this gives us the value of x is 1.9 into 6.9 over 5.7, that is equal to 2.3. So we get that the value of Pn is 2.3. So the value of PR, we have it is 2.3 plus 6.9, that is equal to 9.2 centimeter. Now in this next question we have AD, this length we are talking about, over DB, DB is this length, is equal to AE, AE is this length, over EC, EC is this length. These are equal, and angle ADE, that is equal to angle ACB. We have to prove that triangle ABC is an isosceles triangle. So suppose we are saying this angle is x and this angle is x. Now AD over DB, that is equal to AE over EC. So this thing gives us that DE is parallel to BC. These two lines, these are parallel to each other. If these two lines are parallel to each other, then this angle is x and this angle is also x. That is, these two angles, these are the corresponding angles. But it is given in the question that these two angles, we are saying this angle x and this angle x, these are already equal. So we have that these angles over here, this angle at B and this angle at C, these two are equal. So what we get is that the side opposite to this is AB and side opposite to this it is AC. So if angle ABC, this is equal to angle ACB, then we have AB is equal to AC, and this thing proves that the triangle, given triangle, is an isosceles triangle. Now next we are given that M and N are the points on the side AC and BC of the triangle ABC, and we are given some conditions over here. The value of these values, these are given to us, and based upon these values we have to check whether this MN and AB, these two lines, these are parallel to each other or not. We are talking about, we have to prove whether these two lines, these are parallel to each other or not. Now in the first part it is given that CM, this length we are talking about, this is 4.2 centimeter, MA is 2.8 centimeter, NB is 3.6 centimeter, and CN, this is 5.7 centimeter. So we are talking about the ratio 4.2 over 2.8. The answer we get, it is 3/2. And the second ratio we are talking about, it is 5.7 over 3/6. The answer we are getting, it is 19/12. And we are saying both these values, these are not equal. So it means these two lines are not parallel to each other. Next we have MA. In the next, it is given that CB, we are talking about this length CB, it is 6.92 centimeter. CN, this length we are talking about, it is 1.04 centimeter. CA is given to be 1.73 centimeter, and CM is given to be 0.26 centimeter. So we are saying 1.73 minus 0.26. What we are left with is, this is the value MA we are left with, and the answer we have, it is 1.4 7 centimeter. This NB we are talking about, this length NB, this is 5.88 centimeter. So if we talk about the values CM over MA, then the answer we have, it is 0.26 over 1.47, that is 26 by 147. Similarly, if we calculate the value corresponding to this side, we have Cn over Nb, that is 1.04 over 588, that is equal to 26 by 147. So what we see from this is, this value is 26 by 147, this value is 26 by 147, so both of these are equal. It means both these lines, these are parallel to each other by the converse of basic proportionality theorem. Now in the last part, we are given CM, this is 5.1 centimeter. CA is this length, whole length we are talking about. This length CA is 6.8 centimeter. CB, we are saying this is 5.6 centimeter, and NB we are saying this is 1.4 centimeter. So if we calculate the value of this CM, we get it is 6.8 minus 5.1, that is 1.7, and value of this Cn we have, it is 4.2 centimeters. Now if we calculate the ratio Cm over Ma, it is 5.1 over 1.7, that is 3:1. If we calculate the ratio corresponding to this side, it is Cn over Nb, that is 4.2 over 1.4, that is equal to 3:1. So what we get is that both these lines M and NAB, these are parallel to each other. Next, in the given figure DE, we are talking about this line. This is DE. This is parallel to AC. These two lines, these are parallel to each other. Second thing that is given to us is that this line DF, this is parallel to AE. These lines, these are parallel. We are saying these two lines, these are parallel, and these two lines, these are parallel to each other. We have to prove that BF over FE, we are talking about this length, BF over FE, that is equal to BE. We are talking about the length BE over EC. We have to prove this thing. So if we look at the triangle we are talking about, this is our given figure. In this, first of all, we are talking about the triangle BAE. We are talking about this triangle over here. In this triangle, we are saying we are having 2 points over here, D and F, and we have joined these 2 points. So for these 2 parallel lines, I am talking about this triangle over here. For these 2 parallel lines, what we have is that BD over DA, that is equal to BF over FE. Now if we consider the triangle BAC, we are talking about this larger triangle BAC. In this triangle, we are saying the 2 lines which are parallel to each other, it is the line we are talking about, it is AC and DE. These 2 lines, these are parallel to each other. So in this triangle, the result we have, it is BD over DA, that is equal to BE over EC. Now we have 2 equations. This is equation number 1 and this is equation number 2. Now from these 2 equations, we get that BF over FE, that is equal to BE over CE or EC, and this is what we have to prove. Next we have in the given figure DE, we are talking about this line DE and OQ. These 2 lines, these are parallel to each other. These 2 lines we are talking about. And DF, this is the line DF, this is parallel to OR. these are the two lines we are saying these are also parallel to each other. We have to prove that this EF is parallel to QR. We're talking about we have to prove that this EF and QR, these two lines, these are parallel to each other. So in the triangle POQ, this triangle we are talking about, in the triangle POQ, we are saying this ED and OQ, these two lines, these are parallel to each other. So what we have is that PD over DO, that is equal to PE over EQ. We are saying this PD over DO, this is equal to PE over EQ. We are talking about this triangle. These are the two parallel lines, so we get this result. Second, we are talking about the triangle POR. We are saying this triangle POR is there. I am drawing this over here. This is POR and PR. These are the two parallel lines that we have. So in this triangle, the result we are having is that PD over DO, that is equal to PF over FR. So from both these equations, what we get is that this side PD over DO, this is common or equal in both of these. So what we get is that PE over EQ, that is equal to PF over FR. Now if we look at the triangle PQR, the larger triangle we are talking about, what we have is this length PE over EQ. We are saying these two sides we are talking about, that is equal to PF over FR. We are talking about these two sides, the ratio of these two are same. So from the converse of basic proportionality theorem, we say that this EF and this QR, both these lines we are saying these are parallel to each other. This is by the converse of the basic proportionality theorem. Now next we are saying in the given figure LM, this is side LM, this is parallel to CB, and LN, this is parallel to CD, and we have to prove this result that AM over AB, that is equal to AN over AD. So what these sides are, we are talking about this is AM over AB. We have to prove this is equal to AN over AD. We are talking about these sides over here. So first of all, we are considering this triangle AML. In this triangle, we are saying these two sides, these are parallel to each other. Now we are writing it is AM over AB. AM means I am talking about this whole side AM, and AB means I am talking about this smaller portion AB over here. We are saying this value, this will be equal to, it is AL over AC. This is AL over AC. Similarly, we are saying AN over AD, that will be equal to, we are talking about this is the side AN, this is AD, this will be equal to AL over AC. Now look at these two sides over here, it is AL over AC, both of these. So what we are left with is the other side over here, this is AM over AB, AN over AD, both of these will be equal, and this is what we have to prove. Next is in the given figure AB is parallel to DE. So these two sides we are saying that AB and DE, these are parallel to each other. Similarly, this BD and EF, these two are parallel to each other. We have to prove that DC square, DC means we are talking about this side, DC square, that is equal to CF. CF is this much portion into AC. AC is this whole length we are talking about. So we can look at this result in the form, we are saying it is DC over AC is equal to CF over DC. So it means what we are talking about, that this side DC, we are saying this is DC over AC. AC is this complete length, we are saying this is the length AC. Then we are saying it is CF, this is our length CF, and this is the length DC. This length we are talking about, this length is DC. We have to prove this thing. So if we look at this triangle ABC, we are having these two sides, these are parallel to each other. So corresponding to these two sides, we are saying we are having this AC over, we are writing it is CD, because the result we want in these two values, for corresponding to these two values, these will be equal to, we are saying BC over CE. We are talking about it is this over this smaller portion. Similarly, if we consider the triangle CDB, we are saying these two sides, these are parallel to each other. Now if these two sides, these are parallel to each other, what we get is that this CF over FD we are talking about, or the result we want, it should be this CB. We are saying the result we want, we are not writing it in this form, we are writing it as CB over CE, that will be equal to, we are talking about this CB over this smaller part CE, that will be equal to this CD over the smaller part is CE, now the smaller part it is CF. Now if we look at these two values, it is BC over CE, this value is also BC over CE, this value we are saying, we are writing CB, or you can write it as BC. So we are saying these two are also equal, that is AC over CD, that is equal to CD over CF. If we cross multiply these terms, we will get it as CD square, that is equal to AC into CF, and this is what we have to prove. This is the result that we have to prove. Next, in the given figure, PQ is given to be, we are saying this is PQ, this is given parallel to AB. Then this PR, this side we are talking about, this is given parallel to AC. We have to prove that this third side we are talking about, these two we have to prove that these two sides, these are also parallel to each other. So if we consider the triangle OAB, we are talking about the triangle OAB. Now in this triangle, we have these two sides, these are parallel to each other. So what we get is that OP over PA, that is equal to OQ over QB. Similarly, if we consider the triangle AOC, in this triangle we are saying these two sides, these are parallel to each other. So from this what we get is that OP over PA, that is equal to OR over RC. We are talking about these sides over here, these are proportional to each other. Now the left hand side of both these equations, they are same. So what we get is that OQ over QB, that is equal to OR over RC. That is, if we look at the figure again, we are talking about this is, look at this triangle over here, we are talking about this triangle. So in this triangle we are saying OQ over QB, that is equal to OR over RC. So this gives us that these two sides BC and QR, these are parallel to each other. Next is in the given figure, in triangle ABC, angle B, this is angle B, and angle C, these are given to be equal. So if these two angles, these are equal, it means we have AB is equal to AC, and BD, we are talking about this length, BD and CE, these two lengths are given to be equal. Now we are saying these whole lengths, if these two values, these are x, suppose this value is y, then this value we are saying it is y. We have to prove that DE is parallel to BC. So we are talking about this length AD, this value is x minus y. This length AE, we are saying this value is x minus y. So what we get is that AD over DB, that is equal to AE over EC. Both these values, these are equal. So this gives us, by the converse of basic proportionality theorem, that DE is parallel to BC, that these two are parallel to each other. Now next, in triangle ABC, D and E, we are saying this point D and this point E, these are points on AB such that this AD length, that is equal to BE length. If DP, this is DP we are talking about, is parallel to BC, and EQ, we are talking about this EQ, this is parallel to AC, these two are parallel to each other, then we have to prove that PQ is parallel to AB. We are talking about, we have to prove that this PQ and AB, these two are also parallel to each other. So first of all, we are considering the triangle ABC, this larger triangle, and it's this triangle, we are saying this DP and this BC, these are parallel to each other. So corresponding to these two, what we get is that AD, this side AD over DB, that is equal to AP over PC. This is equal to AP over PC. And in triangle CBA, we are talking about the triangle CBA. That is the same triangle we are talking about. Now the next we have, it is this EQ and AC, these are parallel. So what we get from this is that BE is this portion over here, this is BE over EA. EA is this length we are talking about, that is equal to BQ over QC. This is BQ over QC. So now in the question, it is given that AD and BE, these are equal to each other. So we can replace this BE with AD. Now if we look at this term EA, we are saying EA will be equal to ED plus DA. We are talking about this AE, that will be equal to ED plus DA, and that is equal to DE. We are talking about this length DE is there, plus the length EB. Why we are saying this? We are saying this is equal to the length ED plus BE. You can replace either this with AD or you can replace this with BD. So what we get from this is that this value we have, it is E or DB. So this whole equation will become the numerator part. Over here we have AD, this BE is equal to AD, and this EA is equal to DB, that is equal to the right hand over here, it is BQ over QC. This is already there, it is BQ over QC. So we are saying the left hand side of this equation is AD over DB. The left hand side of this equation is AD over DB. So right hand side, by comparing the right hand side, we get AP over PC, that is equal to BQ over QC. Now if these two are parallel, that is AP, we are saying this is parallel to over PC. We are saying AP over PC. We are writing these two terms, AP over PC. We are saying this is equal to BQ. BQ is this portion and QC is this portion. This is BQ over QC. So we are saying if these two are equal to each other, it means this line PQ we are talking about, this line PQ, this is parallel to AB, and this is what we have to prove. So we are saying by the converse of Thales theorem, we have PQ is parallel to AB. Now next we are given if three or more parallel lines are intersected by two transversals, prove that the intercepts made by them on the transversal are proportional. So we are saying these are the three lines, suppose we are considering, it may be more than three lines can be there. We are saying these are intersected by two transversal. This is one transversal, this is another transversal. We have to prove that the intercepts made by them on the transversals are proportional. That is, we have to prove that this PQ over QR, this is equal to EF over FG. We have to prove this thing. So we have done the construction over here, and the construction is we have drawn PM. PM is this line we are talking about. We have drawn this line PM parallel to this CD, and it is meeting this point, this line L at P, this line M at L, and this line N at M. We are talking about these 3 points. This is P, L and M. These are the 3 points that we have now. Now if we look at this figure over here, we are talking about PEFL or PMGE. What we have is that this PE and BG, these are parallel. These 3 lines, these are parallel to each other. These lines, these are parallel to each other. It means it forms a parallelogram. So if length of this PL is X, then this EF is X. Both of these, they are equal to each other. If length of this, we are talking about LM is Y, then this FG length, it is also equal to Y. Now look at this triangle over here, PQ, this triangle PRM I am talking about. I am drawing this triangle over here. This is the triangle we are talking about. This is PRM, and we are having 2 points over here. One point we are saying it is Q, and second it is L. We are saying these 2 lines, these are parallel to each other. This is X and this is the ratio. We are the length, we are saying these are X and Y. Then what we have is these 2 lines, these are parallel to each other. So by basic proportionality theorem, we are saying PQ over QR, that is equal to PL over LM, that is equal to X over Y, and this value, this is equal to EF over FG. And this is what we have to prove, that the intercepts made by these 2 transversals on the parallel lines, they are proportional to each other. Now in this next question, it is given that ABCD is a quadrilateral and PQRS are the point of trisections of the sides given. So trisection means if this length is X, then this length is 3X. It is 1/3 over here. If this length is Y, this length is 3Y, this length is Z, then this whole length we have, it is 3Z, and if this length is say T, then this whole length is 3 times T. This is given to us. We have to prove that PQRS is a parallelogram. So to prove this, we have done the construction and we have joined these points A and C. Now if we look at the triangle BAC, this triangle we are talking about, ABC triangle we are talking about. In this triangle, we have, this is X and this whole is 3 times X. We are saying this is Z and this whole is 3 times, this is Y, then this whole is 3 times Y. So what we get is that these 2 lines PQ and AC, these 2 lines, these are parallel to each other by basic proportionality theorem. By the converse of basic proportionality theorem. Now if we talk about the triangle DAC, what we have is Again, the similar kind of condition we have, that if this is t, then this whole length it is 3t. If this is z, then this whole length this is 3z. So what we get is that these two lines, we are saying these are parallel to each other. So combining these results, we obtain that SR, this line we are talking about, this is SR, this line is parallel to PQ. This is the line PQ we are talking about. These two lines, these are parallel to each other. Now similarly, if we do the construction that we join this point B and D, and we consider these two triangles. Once we consider this, you have suppose in the first figure I have joined these 2 points, and now I am considering the triangle BDC, and second triangle is DAB. These two triangles we are considering. So for these two triangles, from these conditions we will obtain that this SP and this QR, these will be parallel to each other. So opposite sides of this quadrilateral PQR, as they are parallel to each other, so we obtain that this PQRS is a parallelogram. Now in this next question, ABCD is a trapezium with AB parallel to DC. We are saying these two sides, these are parallel to each other. E and F, these are the points on non-parallel sides A, D and BC, such that EF, this we are talking about, this is EF, and AB, these are also parallel to each other. It means what is given to us is that this line DC, this EF and this AB, all these three lines, these are parallel to each other. We have to show that AE, we are talking about, this is AE over ED, this is equal to BF over FC. So to prove this, what we have done is we have joined these points A and C, and D is the point where this AC meets this EF. Now consider the triangle ADC. We are talking about this triangle ADC over here. In this triangle we have AE, we are talking about, this is AE over ED. We are saying these two lines, these are parallel to each other. So we get AE over ED. This is equal to AG over GC. This is AG over GC. This is by our basic proportionality theorem. Similarly, if we consider the triangle CAB, we are talking about this triangle CAB. In this triangle, we are saying GF, this line and this line, these two lines, these are parallel to each other. So from this triangle, what we get is that AG over GC, that is equal to CF, this is BF over FC. So by combining these two results, we see that the right hand side over here and left hand side over here, these values, these are equal. We obtain that AE over ED, that is equal to BF over FC. So this is what we have to prove, that AE over ED, that is equal to BF over FC. ABCD is a trapezium in which AB is parallel to DC. So over here what is given to us is that A, B and DC, these are parallel, and it is a trapezium over here, and its diagonals intersect each other at the point O. The diagonals of this trapezium, that is AC and BD, they intersect at the point O. We have to prove that AO over OC, that is equal to BO over OD. So to start the proof, we have drawn a line passing through O and parallel to AB, which meets this AD at this point E. We have drawn this line which is parallel to these two lines. Now consider the triangle ADC. We are talking about, we are considering the triangle ADC. In this triangle, we have EO and DC. These are parallel to each other. So what we get is that AE over ED, that is equal to AO over OC. Next, when we are considering the triangle DAB, we are now considering this triangle DAB. In this triangle, we are saying we have DE, that is this side we are talking about, over EA, that is equal to DO over OB. So this term we are saying this is AE over ED. These terms we are saying these are these terms. So if we look at this term over here and this term over here, by combining the result, what we get is that these two terms, when we are talking about, we get AO over OC, that is equal to OB over OD, and this is what we have to prove. Now in the next question, the diagonals of a quadrilateral ABCD, it is given that they intersect each other at the point O. So this quadrilateral is given to us, and these are the diagonals of this quadrilateral. This AC and this BD, these are the diagonals of this quadrilateral, and they are intersecting, these diagonals, they are intersecting at point O, and this is given that AO over OC, that is equal to BO over OD. So to prove this, we are going to do the construction over here, and the construction is that we have drawn a line OE parallel to DC. This E is the point where it intersects with AD, and these two lines, these are given to be parallel to each other. So if we consider the triangle ACD, we are talking about this triangle ACD over here. In this triangle, we have these two lines, these are parallel to each other. So what we get is that AO over OC, that is equal to AE over ED. We get this thing. This is by the basic proportionality theorem. But it is given to us that AO over OC, this is equal to BO over OD. We are talking about this thing is given to us over here, that this AO over OC, that is equal to BO over OD. Now if we consider the triangle DAB, we are talking about this triangle DAB. Now what we have is that BO, this over OD, that is equal to AO over OC, and that is equal to DE, or we are saying AE over ED. So what we are talking about is that this side DE, and if we look at these two values over here, these are proportional to each other. So from these two terms, what we obtain is that these two lines, these are parallel to each other. I am again explaining this, that if we consider the triangle DAB, we are talking about this triangle DAB. In this triangle, we have this point is E and this point is O. AE, this length is AE over this length is ED, that is equal to BO, and this length is OD. These are proportional to each other. If these are proportional to each other, this thing gives us that this OE and AB, these are parallel to each other. These two lines, these are also parallel to each other. Now what we have assumed first, the first thing, that is we have in the construction part, what we have done, this OE line, we are saying this is parallel to DC by our construction. Now we are saying that this line OE and AB are parallel to each other. So combining these results, we get that AB is parallel to DC, and this thing proves that ABCD is a trapezium. Now next is in the given figure ABCD is a trapezium in which AB and DC, these are the two parallel lines, and its diagonal intersect at O. If AO, the length we are talking about, it is 3x minus 1. OC length we are saying it is 5x minus 3. BO length this is 2x plus 1. And OD length it is 6x minus 5. We have to find the value of x. Now from the previous question we have proved that AO over OC, that is equal to BO over OD. This is from the previous questions, we have proved this thing. So what we get is that 3x minus 1 over 5x minus 3, that is equal to 2x plus 1 over 6x minus 5. So if we cross multiply these terms, we get 3x minus 1 into 6x minus 5, that is equal to 2x plus 1 into 5x minus 3. On solving this, we will get the quadratic equation 2x square minus 5x plus 2 is equal to 0. If we split the middle term, we will get x minus 2 into 2x minus 1 is equal to 0. So this gives us x is equal to 2 or x is equal to 1 by 2. Now if we substitute the value x is equal to 1 by 2 in the length OC, we are talking about this length OC is there, and we substitute x is equal to 1 by 2, we get 5 into 1 by 2 minus 3, and the final answer is negative, and we are saying this thing is not possible. So this answer is not possible. So answer we are left with is 2. So we are saying that the value of x is equal to 2 satisfies these equations.